Well, welcome everybody to the finale of the INTERPLAY24 exhibition. This has been quite a long journey since December, when the first phase of the competition was run. There were 10 awards then, and one award was for a major project, Planetary Projector. Second award was Balanced Lamp, and then there were £3,000 awards and 5 commendation awards. They were all exhibited at Battersea RCA, and we all had a great time seeing what the entries had won and experienced the creativity of the RCA and Dighton School. This is the second year of our Interplay competition. We focused a little bit more on a size that was manageable rather than large sculptural objects, and this is why Planetary Projector won, because it ticked all the boxes. Over to you.
Thank you, Alec.
Thank you. So, good evening, everyone. Thank you for joining us today for tonight's final exhibition and presentation of our Kinetic Lab Planetary Projector. This project has gone for more than half a year. And so before I begin, I would like to sincerely thank Design Education Trust to support us throughout the way. And firstly, I'll introduce about how this beautiful idea births and also how we realize it. Okay, so this is a really early stage rendering when we have the first phase of this project. And in brief, the Planetary Projector is a combination of dynamic sculpture and also a ambient light to light up the space. And it has 2 states, dynamic mode and static mode. And yes, this is our team. We consist of Tong and me. Tong is with the expertise in mechanical engineering, and I'm with the background of interaction design. Our very initial inspiration coming from chaotic motion. This is an early stage prototype Tong and me doing in the lab to try and prove the execution of this chaotic movement. And yes, you can see that it's really beautiful, random, and unpredictable moving. And at the same time, it has the certainty in this chaos, which is like anchored by a fixed pivot point in the middle. So that's why this really attracts us. Like, you can actually find chaotic motion in our everyday life, even in the universe, like the solar systems. It looks, at the first glance, it looks like moving orderly, but actually, if you are understanding it from a bigger and larger time and space scale, it's actually moving chaotically. And if we take a closer step to our everyday life, we all have those difficult, chaotic moments, and many unexpected things just happen in our life. And at this point of time, it's those really, really stable, like in the heart. It can be religion, it can be brave, it can be tenet, it can be values to support us back to the ground and keep going. So that's where the static core is so important in our daily lives. And this kind of concept, when it comes to our design, it turns into these 2 modes. One is dynamic mode, where you can see the 3 orbits, like the planet orbits rotating, but the center core is always in the middle, stable. And in the static mode, the 3 orbits will come into a balanced mode, just like your facilitator, which is symbolizing those concentration, focus, and those stable present in the universe. To bring the design to life, we actually take iterative process to try the structure, like for example, testing on these movements to ensure that it can cater to both chaotic motion and stable states, to test on the waist and length of the arms. And yeah, here's a look of our design process. Yeah, they're all moving all together. But for the first one, you can basically see this is how we started with the CAD, the modeling of this lamp, the test of sensors that the magnetic switch that the light will be on when all the three arms balanced and aligned, and the building process, and the movements of the dynamic, and also, of course, the last step when everything is integrated, it can lead up and back to the balance mode, and the light will be on. And we also explore a range of aesthetic direction for this lamp's form. And the final presentation, the final design is minimalistic and focusing on the stability of the centerpiece, which emphasizes the importance of this stable core in the daily lives. And yes, this is our first generation prototype that if you happen to see it in the last winter, we participated in this Interplay final exhibition in RCA Battersea. You can see there is a infrared sensor to detect your gestures, like a simple wave will allow it to transit seamlessly between dynamic mode and static mode, which Tom will explain the details shortly.
Yeah, okay. And here's come to the boring part, the engineering part, but I believe some of you appreciate it. And although we're exhibiting the new prototype today, but this is what brought us here. This is what we produced in December to win the competition. And I think it's worth introducing it to everyone. So, as you can see, it was moving much faster compared to what it is right now. And it's moving a chaotic motion, and it was only driven by the first stage motor. And to achieve that, we actually had a little clutch that can move up and down to engage and disengage the motor. This was quite genius in a way that it's purely mechanical, but it has suffered reliability issues. And this is in the first prototype how we used to manually flip up the arms to align all the stages to light up the LED and to come back to balance mode. And now we've of course changed to automatic motion. Yeah, and again, the previous model relied on passive balancing, which is just adjustment of center of weight. And after that, we won. And again, thanks to Alec and the Design Education Trust to give us the opportunity to develop everything further. And of course, we didn't stop there, and we did something with the money. Yeah, we made it better, of course. So this comes to our second prototype, or actually it's more than second, it's about the fifth prototype, but we call it officially the second one. First of all, we drastically improved the build quality. We changed the center silicone probe to a PMMA light diffuser, and we moved to a glass fiber construction so that it's more heat redundant and also much more rigid. And then this one is designed for manufacture. The first one was 3D printed. This one is also 3D printed. But the biggest difference is that the first one can only be made in 3D printing, but this one we sliced it in half, and now everything is two-dimensional, and it can be injection molded if we move to mass production. And of course, the most important one, the motion. The first one was fast, and it was sometimes too fast. We changed the entire motion logic. Now it has two stages of motor, and both the first and second stage can move in a controlled manner. And that was achieved by a custom-made slip ring, which we designed, made, and ordered. It was bespoke, and because there was no available parts off the shelf of that size. And then we made the finish much better. We have hidden all the sensors, all the fasteners, and to achieve this simplicity and to make it look much more beautiful. Yeah, and that is our final product, and you must have seen it from the outside, and we can probably do another live demo once we finish this presentation out at a gallery space. And here's a summary of our improvement since last December. And of course, this is not where we will stop. We will have even more improvements. Oh, sorry. Yeah, so one big thing that we want to scale up the entire project, we want to be much bigger. And then it can move even slower and will kind of more mimic the majesticness of our solar system. And we want to build it in metal body, if possible, so we can have variants. The injection molded plastic ones will be, let's say, the mass one, and we can have some more premium for the better quality. And of course, we can have smaller and thinner PCB boards. We can custom order the circuit board. Now we're relying on Arduinos, but with more development, we can shrink the service module. And of course, mass production capability. We have improved on that a lot, but we can do more on that. And that is from us. Again, thanks everyone. Thanks to the And perhaps we have some questions.
It's been quite a long journey, hopefully enjoyable one as well as challenging. When the competition was announced about a year ago now, what inspired you to actually enter? Did you have a reason for you'd like to say?
Do you want to go for it or? Yeah, so the competition was announced alongside our other project at Imperial. It's called a Cyber Physical System, and a lot of other entries, they were actually part of the module, but we decided to enter individually outside of the module because we want to explore more into the concept, because we thought the kinetic sculpture and light, the combination itself was more interesting than the limitation that our course might have proposed. Because for that one, it kind of have to be a robotic project. And yeah, I think this project itself interests us more, and then we decided to enter. Yeah.
Yep. And yeah, also like, because that time our modules are quite broad, and so it might be not so like product delivered when you're starting firstly beginning a module. And both Tong and I have the passion to design something interesting, and we're quite interested in the lightings as well. Like personally for me, because my grandfather is also an engineer, and he pays a lot of attention in how the lighting systems can be applied into the pods and constructions, which sort of encouraging me to discover more about this field, and also like the kinds of motions and well, it's always so beautiful that allows me to connecting them in my daily lives. I was thinking, what kind of philosophy can we feel from that different motions and kinetic movements, which inspire me a lot to participate in this competition. Yeah.
Mm-hmm. Good. Any other questions?
So I was just going to ask about what you found the most rewarding while working on this project.
For me, it will be quite different because I came from a very hardcore background, and shout out to my friends at UCL. I was a rocket engineer and I was actually doing rocket science, and coming to this was actually quite difficult and different for me. And having a partner that has a lot of experience in design, and my classmates now, they always say bad words about me, saying that I don't have any sense of aesthetic or I don't have any sense of design. But I think
being that rude.
Yeah, I know everyone's being rude at me, but that's fine. I'm starting to accept it, and I do feel the most rewarding part is that when I finally came up with something that they can call it beautiful, and usually we don't care about that, but now I care a bit more about that. Yeah.
Yeah, Thomas used to say that he thinks this is the most beautiful work he has ever made. Yeah, and yeah, for me, for sure, like one of my motivation to join IDE was because I want to know more expertise or knowledge across disciplines, and of course engineering is part of them. And it was great to collaborate with Tong in this project because he has a really much expertise in engineering and managed to execute and realize this beautiful idea lively. And during this whole process, I get to know more about lighting, and including the lighting systems and mechanisms inside it, which is a really enriching experience for me as well. Yeah.
Thank you.
you went through 5 prototypes, not just 2. The profile is 2, but what was the most difficult part of the project to achieve? What was a real problem to overcome?
I think the real difficult problem is different to me and her. For her, a lot of it comes to convincing me, and no, actually, I was quite stubborn on many subjects, and I do think the engineering, they do eventually come together, and engineering the technology was always there, right? It's just we need someone to make use of it. And it's like making a puzzle, but you don't know the answer of the puzzle. And putting it together, that was the most difficult part for me. Because, as I said, we don't know what the answer looks like. And designing without a brief, that was it's the first time for me. So, yeah, that was hard for me. And I believe you must have something different that's hard for you.
Yeah, I would say I was already sharing as I shared in the first phase, that this whole experience was really fun and enjoyable because of the smooth collaboration and also our passion of the lightings. And I think, as Tom mentioned, the kind of collaboration does bring, the cross-discipline collaboration does bring some challenges during this process, but at the same time, it also contribute to it. You can see, from the final work, including those fillet angles on the orbits. As an engineer, he always like to keep all the sharp angles when doing the 3D modeling, for example. So it's not easy to fail. It's easier for the execution. But from a designer perspective, I may thinking, okay, these short angles might hurt people's fingers. It might not so good aesthetics. But I think we're all quite satisfied from about what we have today, and for sure there are still a lot of things that we can push further, and we hope we can make it better in the futuristic phase.
That leads me to another question. It's slightly larger than the original prototype, I think 45%, and you've indicated here that you might want to make it even bigger.
Yes.
Yeah. Would you like to see it as a sculpture in a gallery in the future, or in the shops even? Is there or both?
Yeah, I think we're aiming for both, because we left a lot of opportunity to be explored. We can have plastic, which is cheap and easy to make. We can have metal, which is more premium and probably has more steady movements. And I think the size of it right now is perfect for desk lamp, or let's say a bedside lamp. But for exhibition or for installation, it has to be bigger to show the movement. And actually, when it gets bigger, it's actually easier to make it move even slower because it has more mass and inertia to it. We can make the movement more elegant and more smooth. So I could totally see it in a shop and in exhibition and galleries in the future.
That's good to hear. I think we'd like to see things make their way into the world eventually, and there are probably various variations, to think about. What kind of advice would you give to people entering Interplay again that might help them from your experience?
I think definitely get a very diverse background team. That has really helped me a lot. I mean, it does cause some emotional issue, but it helps a lot. And be more open to ideas, to all kinds of ideas from everyone. And also appreciate technology more, because I think some other project, not necessarily inside Interplay, but generally in design engineering field, some of them are beautiful, but they don't work, and you can't produce something that doesn't work, right? So appreciate technology is something I would say definitely very important. Of course, I'm also appreciating design more. So.
Oh, really happy to hear that. My suggestion will be, if you're participating in Interplay next year, for sure you're going to be really passionate and loving what you are designing for, because actually you are all standing at a really good platform and with various opportunities, and you have your precious time that you want to focus on, that contribute in actually putting efforts into such an object for such a long time, not only requires that our cooperation, the support of Design Education Trust, but your really determination and hope that it's a really beautiful idea and you want to make it better. And this all comes from the passion and enthusiasm when you firstly start to enter the entry. Like we are participating in this competition not for the reward, not for many other things, but you have to be really interested in what you are designing at the very first place, and that actually you can see, you can feel it from your final work. That's really easy to tell. And for our project, for sure, we are so enjoyable during the whole process, including the very initial stage. We were thinking, even if it's not getting award for this exhibition, for this competition, is still such an enjoyable and happy experience for us, and I think that's a really good start for us to keep pushing this project at a very early stage.
On behalf of the Design Education Trust, I'd just like to say we're very impressed with your work ethic and your outcome, and we wish you every success in the future. And I'm sure we'll see more about Planetary Projector in due course. So I'd just like to ask everybody another round of applause for a marvellous finale of this project.